Hey friends, hi, welcome back to Ekansh Academy. So in the last lecture we had covered characteristics of circular motion and kinematics of circular motion. So today we'll be focusing on uniform circular motion. So let's begin with uniform circular motion. So in uniform circular motion, the first thing that is there is the speed is constant. The speed is constant. The second thing is that the angular velocity in uniform circular motion is also constant. The third thing is that the direction of the velocity is continuously changing. ठीक है. So speed जो है वो constant रहेगा, angular velocity जो है वो constant रहेगा, direction of the linear velocity will be changing. So what is the direction of the linear velocity? If I draw this, if this is the circular motion, so at any point of time, so this time it is here, this time it is here, so the direction is keep on changing. So uniform circular motion may be the direction of the velocity is changing. So what is the factor that is causing this velocity to change its direction? There should be some acceleration taking place here that is making this velocity change its direction. Okay, so that acceleration we call it as centripetal acceleration, which acts towards the center of the circular motion. It is this acceleration which keeps this velocity always tangential to the path of the circular motion. So centripetal acceleration. So in the last two lectures we have in the last lecture we had covered this characteristics and the kinematics. In that we have covered two formulas. Okay, what were those formulas? I'll write it here. V is equal to R times omega, and the second one was omega is equal to 2 pi n. Okay. So today we will be calculating the centripetal acceleration that is required for this uniform circular motion to take place. So that centripetal acceleration is v square by r or omega square r. So let's see the derivation of how to derive this omega square r. Okay. So we know that v is equal to r omega. Okay. V is equal to r omega. अब हमें क्या we know that omega is actually constant. ठीक है, omega जो है हमारा angular velocity is constant. तो हम लोगों को डेरिवेटिव लेना है दोनों साइड में with respect to time. So it would be dv by dt is equal to, since it's a constant, it will come out, it will become dr by dt. ठीक है. So now what is dv by dt? It is nothing but acceleration. ठीक है. And omega times what is dr by dt? It is velocity, the change in displacement with respect to time. ठीक है. So now if I replace this v again by r omega, so acceleration will be omega into omega times r, that is omega square r. So this becomes your third formula. Okay, and the direction of this acceleration would be towards the center of the motion. Okay, towards the center of the circular path. Okay. Now one would think that what would be the tangential acceleration in this case? Since the velocity is changing, since the velocity is not constant in our case, so what would be the tangential velocity? Tangential acceleration means at. ठीक है. So see, in this case there is only one acceleration that is taking place towards the center of the circle. So if I take AT would be that along the tangent of the circle would be AC into cos of this angle. ठीक है, हम प्रोजेक्शन देख रहे हैं इस पाथ इस फोर्स का इस साइड पे कितना प्रोजेक्शन हो रहा है. So that is AC cos 90. Now the AC cos 90 is nothing but cos 90 is 0. That's why the tangential acceleration जो रहेगा इस केस में it will be 0. And just because the tangential acceleration is 0, that's why it is a uniform circular motion. ठीक है? So this is the thing. Now let's see what is what would be the. So in uniform circular motion, my angular acceleration will be 0. My angular velocity will be constant. My centripetal acceleration will be v square by r or omega square by r. This becomes our third formula. We'll be keep on recording all the formulas so that in the next videos when we'll be solving sums, at that time it will be useful. Okay. So now we'll understand centripetal force. As we know, the acceleration responsible for this uniform circular motion is centripetal acceleration, right? So the force responsible for this uniform circular motion is m times the centripetal acceleration, that is CPF is equal to m times AC. ठीक है, centripetal acceleration, which is m times omega square r. In terms of, if I give it with respect to the vector, it would be a minus sign as it is acting towards the center of the circular motion. ठीक है? So this centripetal force is the resultant of all the forces that is making this circular motion possible. Okay? Okay. Now let's understand centrifugal force. This is the another formula that we have covered, that CPF का magnitude is equal to m omega square r. ठीक है? Since magnitude में वो minus sign हट जाएगा. ठीक है? The next force that we are going to discuss is centrifugal force. Okay. So centrifugal force is actually not a real force, just like unlike centripetal force. Centripetal force is actually a real force that is making the circular motion happen. But centrifugal force is not a real force, but also it is not an imaginary force. Okay? It is not a real force, but it is also not an imaginary force. ठीक है? So एक question दिमाग में ऐसा आता है कि if there is a force that is pushing this object, or let's say if I am tying, मैं एक stone एक रस्सी को ऐसा बांध के घुमा रहा हूँ, let's say, ठीक है, in this direction, तो there is a centripetal force, ठीक है, this force is acting towards it, तो ये नीचे गिर क्यों नहीं जा रहा है, अंदर क्यों नहीं आ जा रहा है, अंदर आ जाना चाहिए था, बट ये नहीं आ रहा है. In uniform circular motion we are talking, right? जिसमें मेरा speed constant हो चुका है, ठीक है, तो ये अंदर क्यों नहीं आ रहा है? ये अंदर इसलिए नहीं आ रहा है because this force has a non-real force in exactly opposite direction, which is nothing but your pseudo force. We call it a centrifugal force, CFF. ठीक है? तो ये मेरा CPF रहेगा, ये मेरा CFF रहेगा. So in uniform circular motion, the CPF and CFF balance out each other. Okay? So CFF would be nothing but, since it is going away from the center, it would be m omega square r. ठीक है? So we can say that centrifugal force CFF plus summation of all real forces. ठीक है, as I said, centripetal force is nothing but the summation of all the real forces. ठीक है, तो CFF plus summation of all real forces would be equal to 0 in uniform circular motion. If it is not a uniform circular motion, then it might happen that CFF is more than CPF. तो जो पुश रहेगा, जो भी ऑब्जेक्ट है, it will feel like there is a high push on that side. Or if it is CPF is more than CFF, then it will feel like there's a push towards inside. But uniform circular motion में this object won't be able to understand that it is experiencing any force whatsoever. So मतलब अगर आपको मैं एक ऐसे ट्रेन में बिठा दूं जो या मैं एक ऐसे झूला में बिठा दूं जो ऐसे एकदम गोल घूम रहा है, ठीक है, तो अगर मतलब ऐसे गोल घूम रहा है, लेट्स अवॉइड ग्रेविटी यार, ठीक है, तो ऐसे गोल घूम रहा है, तो अगर मैंने आपके आंखों पे चश्मा लगा दिया और इस ये जो रोटेशन हो रहा है, इस रोटेशन को मैं एक यूनिफॉर्म स्पीड के साथ, एक कांस्टेंट स्पीड के साथ अगर घुमाऊं, तो आपको कोई भी सेंट्रीपिटल फोर्स और सेंट्रीफ्यूगल फोर्स, दोनों भी फोर्स महसूस नहीं होगा. क्यों? क्योंकि यू आर मूविंग इन अ यूनिफॉर्म सर्कुलर मोशन. बिकॉज यू आर मूविंग इन अ यूनिफॉर्म सर्कुलर मोशन, ऑल द रियल फोर्सेस जो एक्चुअली टुवर्ड्स द सेंटर ऑफ द मोशन में लग रहा है विल बी इक्वल टू द सेंट्रीफ्यूगल फोर्स. तो वो बैलेंस आउट हो जाएगा एंड यू वोंट एक्सपीरियंस एनी फोर्स. लेकिन अगर यूनिफॉर्म मोशन नहीं रहा, देन अगर सेंट्रीफ्यूगल फोर्स ज्यादा है, देन यू वुड फील लिटिल पुश आउटवर्ड, और अगर सेंट्रीपिटल फोर्स ज्यादा है तो यू विल फील पुश लिटिल इनसाइड. ठीक है, हम ये ट्रेन्स में यहाँ वहां जाते वक्त ये सेंट्रीपिटल और सेंट्रीफ्यूगल फोर्स दोनों एक्सपीरियंस करते हैं. कभी एक ऐसा टर्न आता है तो हम लोग, सिंस इट्स नॉट यूनिफॉर्म, तो हम लोगों को कभी कभी ऐसा बाहर का पुश लगता है, so that is the centrifugal force. ठीक है, so but in uniform circular motion both balance out each other. So centrifugal force is not a real force, but it is also not a imaginary force. ठीक है, so ठीक है, okay, so that's it for this. Okay, अब हम मिलते हैं नेक्स्ट वीडियो में. तब तक के लिए थैंक्स फॉर वॉचिंग.